In our last video, we have discussed about types of solutions. Today, we are going to discuss about how to express the concentration of solutions. So first, let us see what is concentration. What do you mean by concentration of solution? Concentration is nothing but the composition of solution. We express the concentration of solutions in two ways. There are two methods to express the concentrations. And that first one is the qualitative approach. How to express the concentration of solutions qualitatively. So there are two terms, qualitative terms, to express the concentration of solutions. The two concentration terms. One is dilute and second one is concentrated solutions. So what do you mean by dilute solution and what do you mean by concentrated solution? So dilute solution means in this type of solutions, the quantity of solute is less. They have relatively lower amount of solute. In concentrated solution, the amount of solute is more. They have higher amount of solute. Now I will give you the examples for concentrated and dilute solutions so you can differentiate. You take three solutions, 1, 2, 3. In the first solution, you have dissolved 1 gram of sugar in 100 ml of water. In second solution, you have dissolved 2 gram of sugar in same quantity of water, that is 100 ml of water. In third solution, you have dissolved 3 gram of sugar in same quantity of water, that is 100 ml of water. Here, the first solution is dilute when compared to solution number 2 and 3. So this is a dilute solution because here the amount of solute is less. It has a relatively smaller amount of solute when compared to these two solutions. So now this is concentrated solution. This is concentrated and this is also a concentrated solution with respect to the first solution. Now coming to solution number 2 and 3. In these two examples, solution number 2 is dilute and solution number 3 is concentrated solution because here the amount of solute is less. So now when you compare second and third solutions, this becomes dilute. Solution number 2 becomes dilute and this becomes concentrated. When you express the concentration of solution qualitatively, it leads to a lot of confusions. Because with respect to first solution, the solution number 2 is concentrated. With respect to third solution, second solution is dilute solution. So now there is a confusion. So which is dilute, which is concentrated? It's very difficult to determine. So in order to avoid this, we use quantitative terms. See, here we use quantitative terms to explain or express the concentration of solution. Quantitative terms deals with numbers or quantities. So it deals with numbers or quantities. Now let us see these quantitatively expressed concentration terms. There are 7 concentration terms. In that first one is mass percentage. So what is this mass percentage? In quantitative concentration terms, we express the concentrations in terms of numbers or in terms of quantities. So there is no such confusions. So first term is mass percentage, which is known as weight by weight percentage. How do you calculate mass percentage? There is a formula for calculating mass percentage. The formula is mass percentage is equal to mass of the component in the solution. Here component is nothing but solute. We take it as solute. Mass of component or mass of solute divided by total mass of the solution into 100. Here we fix the total mass of the solution as 100 only. It may be 100 gram or 100 kg. So this denominator is always fixed. You know how to calculate the percentage of your marks. The total marks will be always fixed. For example, it is 600 and it is not going to change. Your percentage of score will be decided by the marks you obtained. So this will changes your percentage. Here also, in this case also, the mass percentage of solution depends upon the numerator, that is mass of the component or solute you have taken. And while preparing the solution, total mass must be 100 gram or 100 kg. So you remember this thing. So how to prepare these type of weight by weight or mass by mass percentage solutions? I will give you two examples here. Let us prepare 10% of glucose solution. 10% weight by weight, W by W, weight by weight glucose solution. How do you prepare it? It's very simple. What we have to do? We have to dissolve 10 gram of glucose. You have to dissolve 10 gram of glucose in 90 gram of solvent or in water. 90 gram of H2O or in any solvent. So now, what is the mass of the solution? Total mass of the solution. Total mass of the solution is nothing but mass of the solute plus mass of solvent, and it is equal to 100 gram. So always we have to fix the denominator as 100 only. Now, if you substitute these things in this equation, so what is the mass percentage? W by W is equal to mass of the component or solute we have taken is 10 gram and total mass of the solution is 100 gram into 100. So now the percentage of the solution is 10%. So this is how do you calculate the mass percentage. One more thing is the unit of numerator and denominator must be same. If you take 10 gram of what solute, here also we have to take 90 gram of solvent, not 90 kg of solvent. Similarly, one more example. If you want to prepare 5% of NaCl solution, the saline solution, how do you prepare 5% of NaCl solution? It's very simple. What we have to do? You dissolve 5 gram of NaCl in total mass must be 100. So what's the amount of solvent you have to take? It's 95 gram. The total mass must be 100 gram only. So now this is how you prepare 5% sodium chloride solution, weight by weight or mass by mass solutions. Okay, this is about the first quantitative concentration term. Next, second one is volume percentage. It's very similar to that of mass percentage. Only the difference is here we have taken mass of the component. Here we are taking volume of the component divided by total volume of the solution. Instead of mass, here we take volume, and the denominator in this also is equal to 100. It may be 100 milliliter or 100 liter. That means while preparing the solution, it's always prepared in 100 milliliter or in 100 liter. The total volume of the solution must be 100. Now let us see how to prepare volume by volume percentage solutions. I'll give two examples here also. 35% ethylene glycol. Ethylene glycol is the antifreeze. How do you prepare 35% of ethylene glycol? It's very simple. So here, what's the volume of ethylene glycol has to be taken? How much amount of ethylene glycol we have to take? We have to take 35 ml of ethylene glycol. So now we have to add this 35 milliliter of ethylene glycol into what's the amount of solvent we have to take? The total volume of the solution must be 100 here. So 100 milliliter, that must be 100 milliliter. So what is the amount of solvent we have to take? We have to take 65 milliliter of water, and total volume here now becomes equal to 100 ml, 100 milliliter. Now you substitute these things in this equation. So volume by volume percentage is equal to volume of the component, that is ethylene glycol, is 35 milliliter. So total volume of the solution, it's equal to volume of the solvent plus volume of the solute. So that is equal to 100 ml only into 100. So what's the mass volume percentage? That is 35%. This is how we are preparing volume by volume percentage solutions. One more example. If you want to prepare 75% ethyl alcohol or ethanol. So what we ought to do? How to prepare 70% ethyl alcohol? It's very simple. You take 70 milliliter of ethanol, 70 ml of ethanol, and you add 30 ml of water, H2O. So now we will get 70% ethyl alcohol solution. So this is about the second concentration term, that is volume percentage. The next one, the third one is mass by volume percentage. This is also very similar to that of previous two terms. Here the definition itself suggests M by V. Mass divided by volume. Mass of the component. Again, component is nothing but solute. Mass of the component divided by volume of solution into 100. And what must be the volume? It is 100 milliliter or 100 liter. So how to prepare such type of solutions? Let us see how to prepare normal saline solution. 0.9% M by V solution. Saline solution means salt solution. How do you prepare? 0.9% mass by volume saline solution. It's very simple. What we have to do? We have to dissolve 0.9 gram of NaCl in 100 milliliter of H2O. So this will give you 0.9 mass by volume saline solution. Normally these are used in medicines or in pharmacy. So this is used in intravenous injections. Normal saline solution, 0.9% mass by volume NaCl solution. In all these three cases, in first mass percentage, in second volume percentage, in third one, that is mass by volume percentage, the denominator must be always equal to 100. It may be in terms of mass or in terms of volume.